Good morning. Now we are going to discuss about the preparation of the backlight. So the preparation of the backlight involves three steps. So in the first step is protonation of the formaldehyde followed by electrophilic substitution reaction. In this first protonation, this oxygen is having lone pair of electrons, and these lone pair of electrons are attacked by these H plus ions. Here we are using a weak acid like acetic acid as a catalyst. So this protonation results in the formation of the carbocation or electrophile. So this carbocation undergoes electrophilic substitution reaction with the phenol. So in this phenol, that oxygen holds in a lone pair of electrons. That lone pair of electrons makes this bond to attack this carbocationic center, which results in the formation of intermediate. In this intermediate, that ortho position, that hydrogen atom present in that ortho position has been removed and makes this bond to shift to its previous position, and which leads to neutralize that oxygen atom. So now we are getting orthohydroxymethylphenol. Actually, this phenol is activating group. So we are getting ortho as well as para hydroxymethylphenols. But to prepare this backlight, orthohydroxymethylphenols are very important and highly reactive. So next step is preparation of that novalactone. So in these orthohydroxymethylphenols are fused together by dehydration reaction in presence of sulfuric acid, which gives the formation of linear chain, which is called as a novalact. Here this hydrogen atom and this OH as well as this hydrogen and this OH undergoes dehydration, and it gives the linear chain that is called as a novalact. And the third step, the two linear novalact structures are fused together by dehydration reaction with formaldehyde. So here this hydrogen, this oxygen, this hydrogen undergoes dehydration. Similarly, here also water molecules have been removed, which gives three-dimensional network in where that phenolic linear chains are combined together, are fused together by CH2 molecules. So this is called as a backlight. So next we are going to discuss about the properties and uses of this backlight. So first one is the properties. Backlight is very rigid and hard. That means the surface of the material is very hard because all the molecules are combined together with strong solid bonds. So next one is the scratch resistance. That means it holds a lot of mechanical stress. So it won't be broken whenever we are applying more stress. That is called as a scratch resistance. And another one is infusible. Another one is infusible solid mass. So that means while heating it will not get melting, and finally we are getting infusible solid substance. Another one is resistance to acids. It is not reactive towards acids or salts, and mostly it won't be dissolved in organic solvents because of the presence of that three-dimensional network structure, which makes that solvents cannot be soluble. So another one is alkali. When we are using sodium hydroxide or potassium hydroxide, these phenolic structures are highly sensitive towards these alkalis because of the acidic protons. So here that phenolic groups holds the acidic hydrogen atoms. So that means OH. In that OH, that hydrogen is more acidic. So if we use alkali, that hydrogen atoms, hydrogen H plus ions has been neutralized. So that's why we are saying that towards alkalis, these phenolic groups are this backlight is highly attractive towards these alkalis. So next one is excellent electrical insulating character. That means it won't conduct any electrons because of the absence of conjugated double bonds present in the molecules. So we can use this as a good electrical insulator. So next one is applications. What are the important applications? We can use backlight to prepare or to manufacture the equipments like electrical equipments like switches, plug holes and switchboards. Another, we can use this backlight to manufacture the parts of telephone, radio and TV cabinets. So we can use this in case of paints and varnish, and we can use this for ion exchange resins which are used for water purification technique, where that acidic H plus ions are exchanged with cations like calcium and potassium and other magnesium present in that water molecules. So next one is we are going to discuss about urea formaldehyde resin. So in this urea formaldehyde, first we are going to discuss about the preparation method. So in this preparation method we are using urea and formaldehyde. 1 mole of urea reacts with 2 mole of formaldehyde. Here the reaction is only simply heating. We are removing water molecules between this urea and formaldehyde, and we are preparing dimethyl urea. This is the first step in the preparation of urea formaldehyde resin. So next one is we are rewriting this urea formaldehyde resin in this way. So we are taking n molecules of we are taking n molecules of dimethyl urea. Dimethyl urea. This is dimethyl urea. We are taking n molecules of dimethyl urea, and these dimethyl urea molecules undergoes condensation polymerization, where this OH is replaced with this hydrogen, and here also this OH molecule is replaced with this hydrogen atom. Here also this OH and hydrogen, this OH and hydrogen has been removed as a water. So this reaction is called as a condensation polymerization. So we are getting the three-dimensional network that is called urea formaldehyde resin. So how to put this bracket? Here these hydrogen atoms has been removed as a water molecule with another adjacent dimethyl urea molecule. So we have to leave these hydrogens and make open the bracket at this place. Open the bracket at this place and write fuse all the molecules together where that dehydration takes place. Finally, here these OH ions, this OH has to be removed with another molecule of dimethyl urea as a water molecule. So we have to close this bond before this OH molecule, and we put n times because we are taking these dimethyl urea molecules at n times. That's why we are putting n here. So next one is properties of urea formaldehyde resin. So here these urea formaldehyde resins are light in color. That means they are colorless or simply light color. So we can bake these to produce light or pastel colored objects. So next one, this urea formaldehyde resin withstands more heat. That means it is not affected by heat, and it is not also affected by moisture. So we can say this as a heat and moisture resistance. So next one, this urea formaldehyde resin is having good electrical property, electrical insulating properties. There is no conjugated double bonds here, so we can use this urea formaldehyde as a good electrical insulator. And these urea formaldehydes are having more resistance towards oil, grease, weak acids, etc. The next, it is also having hard and resistance towards abrasion scratching. That means it withstand more stress when we apply. So next, it is having good adhesive properties. Adhesive properties means that gummy nature. It is having lot of adhesive nature. That means lot of gummy nature. So next one is applications. So we can use these we can use this urea formaldehyde. We can use this urea formaldehyde for to mold the articles like a vacuum flask, and we can use this to produce plywood and laminating materials. And we can use this as a cationic exchange resins. Because of that nitrogen atom, we can use that nitrogen sites are acting as a exchangers because of the lone pair of electrons present in that nitrogen atoms. Another, we can use this to prepare electrical switches, plugs and insulators. So next one is nylon 6,6. Now we are going to discuss about the preparation of nylon 6,6 molecules. To prepare these nylon 6,6 molecules, we need two molecules. One is adipic acid, and one is hexamethylene diamine. So here I kept numbers 1, 2, 3, 4, 5, 6, which represents the number of carbon atoms present in there. So in the adipic acid contains 6 carbon atoms. So here this is the hexamethylene diamine. So in this hexamethylene diamine also 6 carbons are there, where at the terminal carbon that amine groups are attached there. So this adipic acid and hexamethylene diamine undergoes dehydration reaction by heating. So this OH and this hydrogen has been removed as a water, and these chains has been fused to give nylon 6,6. The number 6, 6 denotes the presence of carbons. 6 carbons present in the adipic acid as well as 6 carbons present in the hexamethylene diamine. So how to put this bracket? So this OH minus has to be removed as a water with the adjacent hexamethylene amine. So we have to remove this OH and open that bracket and continue everything and fuse this together and continue this zigzag, and finally one of the hydrogen has to be removed from this NH2, which has been gone as a water molecule with adjacent adipic acid. So we have to close with one hydrogen only. So this is called as a nylon 6,6. And next one is properties. What are the main properties of this nylon 6,6? So in this nylon 6,6, these are having highly strength and elasticity. Elasticity means if you give force, that polymer has to be drawn into linear lengthy molecule, that is called as elasticity, and it is having abrasion resistance also. These are having more resistance towards moisture, and most of the nylon molecules are insoluble, that means they are not soluble in common solvents like ethanol, methanol, like that. So next one, these molecules are held together by hydrogen bonds. Hydrogen bond is the bond between a more electronegative atom and the hydrogen. So in this, nitrogen is there, that is the more electronegative atom, and hydrogen is also there. So the bond between the weak bond which has been formed between nitrogen as well as hydrogen atoms of adjacent molecule. It is called as hydrogen bonds. So these are having a linear structure and permitting side by side alignments. So next one, these are the very flexible, and it is having more shape memory. Even if you change their shape, automatically they may change their original shape without using any external force. And nylons provide excellent resistance to wear and abrasion. Wear means resistance towards dust particles to get accommodation on the surface. That is called as a wear resistance. So next one, due to presence of hydrogen bonding, these are water sensitive. Because of the nitrogen atoms, it will easily coordinate with hydrogen atoms of water molecules present in our atmosphere. So due to formation of this hydrogen bond, these are having more water sensitive. And another one is the Nylon6 applications. We can use this Nylon6 to manufacture the automobile card, tire cards, and threads, etc. And we can use these to manufacture textile fibers, to manufacture the dresses and undergarments, socks, etc. And these are the plastic material, and we can use these for metals, use this as a substituent for metals to prepare the gear and bearings, because it is having that much heavy mechanical properties to hold the stress, to hold the barrier. And next one is these nylon 6 can be used to manufacture the rollers and slide doors, etc. And nylon 610 is not used much synthetic fiber. That means in the case of hexamethylene diamine, we can use some other molecule which holds 10 carbons. So, but this is not used as a synthetic fiber, and due to this good barrier property, that means it can hold more weight, and that's why we are saying this as a good barrier properties. And nylon 6 film is used for packing some oxygen sensitive material. That means it can be used to pack some of the oxygen sensitive food materials. So nowadays we are using these plastic materials to fold the food materials in packets. So now up to this we have discussed about the preparation properties, use of backlight, as well as preparation properties and uses of urea formaldehyde resin, and we have discussed about preparation properties and uses of nylon 6. So we can see next topic in next time. Thank you.